Good morning everyone. In this session we will discuss about the degree of reduction. So before going to the degree of reduction, let us have a brief introduction about the elemental balances in the stoichiometric equation that are what we have discussed in the earlier sessions. So what happens exactly during the elemental balances of a stoichiometric equation? So here exactly what is elemental balance? So there is 1 mole of biological materials is defined as the amount containing 1 gram atom of carbon, that is CH alpha O beta N eta. This elemental balance is based on assumption that there are no other extracellular products other than the water and carbon dioxide. But this is in practical, this is not possible. Along with the water and carbon dioxide, there might be the production of some biomass and other extracellular products also. So, but when there is a production of extracellular products, the simple elemental balance will be more difficult. Hence, to overcome this is a elemental balance of a normal elemental balance, that is if there are a carbon source, that it will be in the presence of oxygen, and the nitrogen source, it will be broken down into a biomass, water and carbon dioxide. So this is the elemental balance. If we consider the elemental balance here, the number of carbon atoms is equal to 1 in the reactant equals to the number of carbon atoms present in the substrates, that is in the carbon the end product of the carbon source as well as in the carbon dioxide. Similarly for the hydrogen also, it is m number of hydrogen ions is equal to plus the amount of hydrogen ions present in the ammonia is equal to the amount the molecularity of the hydrogen ions in the product plus water molecule, right. Similarly in the if we consider for the oxygen also, that is N plus 2A is equal to C beta plus D plus E, 2E, that is oxygen is contributed by the oxygen in the reactants as well as the carbon source as well as the water and carbon dioxide. If we consider the nitrogen balance, that is B is equal to C neta. If we want to calculate the respiratory coefficient, it is equal to the E, that is the volume of carbon dioxide released to the A, that is volume of oxygen consumed. So here we have 5 equations and 5 unknowns. So with the measured value of RQ, these equations can be solved to determine the coefficients. But in generally we do not have could not get the respiratory coefficient value. So the elemental balances provide no insight into the energetics of a reaction. So to solve this problem, here they have introduced a concept called degree of reduction. That is, the concept of degree of reduction has been developed and used for protein electron balances in bioreactions. Rather than based on the elemental balancing, this degree of reduction is based on the balancing of protons and electrons. For example, a simple degree of reduction for any organic compound is defined as the number of equivalents of available electrons per gram atom of carbon. If we consider this previous reaction, so the degree of reduction for some elements are for the carbon it is 4, for hydrogen it is 1, for nitrogen it is -3, for oxygen it is -2, for phosphorus 5 and sulfur 6. So this degree of reduction is denoted by the symbol gamma. So these are for example, if we want to calculate for the methane, as methane is the molecular formula of methane is CH4, it contains 1 carbon atom and 4 hydrogen atoms. So 1 into 4 is equals to plus the value of the degree of reduction of a carbon atom is 4 and there is 1 carbon atom, so 1 into 4 plus for hydrogen atom it is 1 and there are 4 hydrogen atoms in a methane, it is 4 into 1. Total the degree of reduction for methane is 8. Similarly for glucose and ethanol also. The glucose reduction value is 4 and for ethanol it is 6. So here if we consider the aerobic respiration, the product, that is the general stoichiometric equation is CHMON plus oxygen plus ammonia gives rise to a biomass and a product plus water molecule and carbon dioxide molecule. Here the carbon source or the carbon source is represented in red color, that is which is acting as a substrate molecule, and the green one is a biomass molecule and the product is represented in orange. So if you want to calculate the degree of reduction of a substrate, it is gamma S, it is equals to 4 plus m minus 2n, because there is a 1 carbon atom and the value of the carbon atom is a 4. So 4 into 1, 4 plus, and there are m hydrogen atoms and the degree of reduction for hydrogen is 1. So m into 1 is equal to 4, and similarly for the oxygen it is minus 2. So minus 2n. Similarly, it is calculated, the degree of reduction of biomass is also calculated similarly, and as well as the product. So for carbon dioxide, water and ammonia, the degree of reduction is 0. Because if we calculate for carbon dioxide, the degree of reduction of carbon dioxide is 4, and there is 1 molecule of carbon atom. So 1 into 4 minus 2 into 2. So it is equals to 0. So similarly for water and ammonia also. So based on the previous equation, these can be using this degree of reduction, we can easily balance the elemental elements within the biological equation, and also we can calculate the available number of electrons, as well as we can balance those electrons also. As a result, we can balance the total energy generated as well as the total mass. So based on all this and every equation is independent of each other. So we can calculate all the equations separately, and none of the equations are dependent on each other. See, for carbon energy, for carbon balancing and nitrogen balancing, and this is electron balancing. So from these equations we can calculate the respiratory coefficient and the yield of the product and yield of the biomass, that is Yxs is equal to the biomass of the product and Yxp is the product yield of the product. So these are some of the self-assessment questions based on the discussion. Thank you.